Okay, here's a map that I created with MindMup. This is a template for reasoning about causal claims. The target audience is a general sort of critical thinking class and not necessarily the person who is learning specific techniques for reading and thinking about scientific studies and controlled experiments. Instead, the goal is to see the more general structure of reasoning about causation and where those kinds of studies fit into the picture. So I usually start with the false cause fallacy, the fallacy of inferring causation from mere correlation. And so what this shows is that you need an extra puzzle piece. That correlation on its own does not support the causal claim that these two claims are under one bar, says these two things are co-premises. They need each other in order to support the claim above. So here's the missing bit. Everything that we're going to use to establish causation is going to support the claim that causation is the best explanation for this correlation. Now, of course, we do want to support the correlational claim, and that will involve having a study where you don't cherry pick the data, blah, blah, blah. So then we can open up and see, well, how do you establish that causation is the best explanation? And so the basic structure is showing that A causes B is a plausible explanation and ruling out alternative explanations. And the three common alternative explanations is the causation could go the other way, so you need to rule out B doesn't cause A, that there could be a common cause, or that it's purely coincidence. And then we also want to support the causal claim beyond mere correlation. Now what I've done is I have put in green the things that require some kind of study or experiment as support, and I have just left in white the things that we can do as critical thinkers in reasoning about causal claims in a more intuitive way. So for the claim that A causes B, if we have some sort of explanation or background model, it fits with other things that we know as a part of our background understanding of the world, that can help to provide some support in conjunction with all these other things. And a controlled experiment would also provide support. One nice thing that MindMup does is allow you to show strength of support. I can't do it in this view, but when I'm creating maps, I can make this bar thicker and this one thinner to show like quality of support for a claim above it. Then likewise for showing that B doesn't cause A, you can start by something more intuitive. There's no plausible explanation, or you could have experiments. Likewise, with reasoning about common causes, you can do it intuitively or try to rule out confounds. And then also I've got the reasoning about coincidence. And so my task for teaching this as a critical thinking topic is to give students a structure for strategically evaluating causal claims. So when you think about a causal claim, correlation is part of the story, but just having this basic structure that the other thing you're doing is looking for explanations for the correlation, causation or alternative ones, and that there are three standard alternative ones to think about ruling out, and that you have an understanding of where the various different studies and controlled experiments fit in. Like, why are we doing these things and how do they connect in to a framework for reasoning about causation? I created this, I just started using argument mapping to teach this material and sort of just created this map of reasoning about causation kind of quickly, and would be very open to receiving constructive criticism on how I've constructed it. But the real important thing for the mapping part of this is just to get students, one, certain kinds of reasoning do have certain structures, like reasoning about causation versus generalizations, whatever. There are common recurring structures. But two is just this, when you're going through reasoning critically about claims, that there are two things you can do. One, does this really support this? For any box, you can ask, does this really support the thing above it? And then the other thing you can do is ask, are these true? So I've set this up to be a strong argument, strong in the sense that if all the boxes are true, we've got really good support for the claim. And then the second step is, are the boxes true? So we can just go to the low-level boxes and try to find ways that these could be false, or find holes in the support if there's further support for these boxes.